Okay, so the 2012 relative velocity question, part B. Ship A is 50 kilometers north of ship B. Ship A is traveling southwest at 24 root 2 kilometers an hour, and ship B is traveling west at 17 kilometers an hour. Let's do a diagram. What's where A is north of B, A and B. B is traveling west, it's going to Galway. Oh no, it's not. That would be overland and it's a ship. So it's going somewhere, America from Galway, and ship A is traveling south or west, this direction, ship A. So we have the velocity of B. We have the velocity of A. Okay, so let's look at these, put them into formulas. We wanted the velocity of B into equations, not formulas. The velocity of B is 17 in the I direction and no J, minus 17 I plus 0 J. It's traveling southwest at a speed of 24 root 2. We know southwest is 45 degrees, so the velocity of A is going to be 24 root 2. So what is it, minus minus? We're going negative negative in this case. Can you see it's negative negative? Where are we going to end up? We'll end up down here, which is negative negative. So minus 24 root 2 by, what's my I? Well, it doesn't matter why, we know it's 45, but let's get it right. My I direction is opposite the 45, so sine 45 times I minus 24 root 2 cos 45 times J. So the root 2's cancel here, so that's going to be equal to, because that's 1 over root 2, minus 24I minus 24J. So that's the velocity of A. So the velocity of B relative to A is B minus A. So we're going to end up at minus 17. That's an A. The velocity of B relative to A is minus 17 minus minus 24, which is going to be plus 7I. And then 0I minus 24J. Sorry, minus 24J is going to be plus 24J. And we're asked for the magnitude and direction of the velocity of B relative to A. So we have enough information to get that. The magnitude of the velocity of B relative to A is, this works out evenly as well. We had this in one of the other relative velocity questions. 7 squared plus 24 squared, the square root of is 25 kilometers an hour. One of your Pythagorean triples. And the angle, the inverse tan of 24 over 7 is going to give 73.7 degrees. And let's see what direction that is. So the velocity of B relative to A is plus plus. Plus plus is up here, so that's northeast. Northeast. Let's draw a diagram to represent part B, or part 2 and 3 of part B. A and B can exchange signals when they are not more than 20 kilometers apart. So we're looking at the closest distance again. At what time can they begin to exchange signals, and how long can they continue to exchange signals? Well, the velocity of B relative to A we found to be in a northeasterly direction. So that's my northeasterly. And we found that the angle was 73.7 degrees. Yep, 73.7 degrees. They start off in this position. B here. No, A at the top, wasn't it? A at the top? A was at the top. And B was here. So this angle, clearly not drawn to scale, is 16.3 degrees. And we have our closest position here with my right angle. And then when they begin to exchange signals, let's say they're somewhere along here and somewhere along here. So what have we got in here? We can definitely get out of this triangle, they were 50 kilometers apart. 50. Let me just double check that. They were 50 kilometers apart. So we have this right angle triangle. Where this is A, we'll call this the point, let's call this X. AX drops down to the foot of the perpendicular. The hypotenuse is 50, and this little angle in here is 16.3 degrees. So we can get this side here, which we will call Y. So O and H, so the sine of 16.3 is equal to O over H. So 50 sine 16.3 is equal to Y. So what does that give us? 50 multiplied by sine of 16.3 is 14 kilometers. 14.03, but we'll leave it at 14. It's not going to make a difference in the answer to this question. At what time can they begin to exchange signals? Okay, so I have my 14. This line here is now the diagonal of this triangle. This is how far they are apart when they can exchange signals. We also have within that diagram, it tells us here when they are not more than 20. So if that's 20, this one is the square root of 20 squared minus 14 squared, which is the square root of 204, 400 minus 196. And if we type that into a calculator, we're going to get 14.28, and that's kilometers. So the difference between the length of, we have this bit here, this bit along here, so we can get the whole thing. We can get this distance in here, which is this, the side of this triangle. Now we can use cos here. We're looking for A, we have H, so the cos of 16.3 is equal to, well, let's call it Z. Z over 50. 50 by the cos of 16.3 is equal to Z. And that will give Z to be 48 kilometers. So the difference between those two, 48 minus 14.28, is going to give us 33.72 kilometers. Now that's not the answer, because they ask us at what time can they begin to exchange signals. So it's going to have to travel for 33.72 kilometers. So that's my distance, 33.72. The speed it's traveling at, what speed was it traveling at? The velocity of B relative to A was 25. So we have our speed. And time is distance over speed. So the time here is going to be 1.35. And if we multiply that 0.35 by 60, we're going to get 1 hour 21 minutes. And the last part, how long can they continue to exchange signals for? Well, how long more is it from this point over to this point? What did we work that one out to be? We got 14.28 for one of these. So we're multiplying 14.28 by 2. 14.28 by 2 is going to give us 28.56 kilometers that they can exchange signals for. And the speed that it's traveling at is going to be 25 again, so just over an hour again. They're going to be able to exchange signals. So 1.14 hours, which is the equivalent of 1 hour and just 9 minutes. And that's that question complete.